Hello everyone, today we're going to be working on the 15s, which is a density lab that you did back in 9th grade science. The whole goal is to figure out the density of this metal block using two different methods. The first thing we're going to do though is we're going to make sure that you know how to measure with a graduated cylinder and measure with a ruler. So if we're looking at these four graduated cylinders, I want you to read the volume. We got this thing right here called the meniscus. And there's the meniscus, and there is the meniscus, and there is the meniscus. We always read to the very bottom of the meniscus to get the correct volume. So we look at these graduated cylinders. Graduated cylinders are going to go up by 1 milliliter, maybe 0.5 milliliters, maybe 0.1 milliliters, and in some weird circumstances, 0.2 milliliters. Those are pretty much what each line would count for on these graduated cylinders. So the first thing is to look at the graduated cylinder and figure out what it goes up by. So here we have 20, and here we have 30, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9 lines between it. So it must go up by ones. Our rule is that your measurement always goes one place smaller than what each line counts for. That is the overall rule. So this is the 21 line, 22, 23, 24, and this is the 25 line. So I am positive that the fluid in this graduated cylinder is at least 25 milliliters. I am absolutely positive of that. Then I look at the meniscus, and I can see the meniscus is definitely off of this line right here. It's actually above it, and it's fairly easy to see that. So if it's fairly easy to see that, it's not going to be a 0.1, it's going to be a 0.2 or greater. So my measurement for this one would be 25.2 milliliters, and we would accept 25.3, and we would accept 25.1 if this was a measurement for you. But 25.2 is what we would believe it to be. We look at this next graduated cylinder, and we have 30 here, and we have 35 there. So this would be 31, 32, 33, 34, 35. So it goes up by the ones place, so we would expect our answer to go to the tens place. So in this one, I'm past the 35, I'm past the 36. I am 100% positive that the value of this is 36 something. I look at the meniscus and look at the bottom of it, and I truly do see that it is more than half of the way up to this particular line. So it's more than halfway. So I'm not going to go 36.5. Could it be 36.6? It could. I actually think it's 36.7 milliliters. Would we accept 36.8? Absolutely. Would we accept 36.6? Absolutely. Make sure you're pausing the video and practicing this on your own. We go to the next one. So this one is 5 milliliters, and this one is 6 milliliters. So each one of these lines would be the tenths place. So our measurement for this one should most likely go to the hundreds place. So it's 5 milliliters, 5.1, 5.2, 5.3, 5.4, and it does not make it to the 5.5. So I am positive of 5.4. Now I look at that. Is it more than halfway? And I do believe that it is above halfway in this problem. So I'm thinking it's a 7. And that could go up to an 8. That could go down to a 6. But I do not believe that the meniscus is exactly halfway between those two. Otherwise, I would have chosen 5.45. Okay, let's go to the last one. So here's 10, here's 20. So it goes up by ones. So I am positive that it is 11, 12, 13, 14. I am positive of the 14 that's there. It does not quite make it up to the 15 mark. It's not really close to the 15 mark, so I can easily tell that it is off that 15 mark. So I'm going to go with an 8. And again, that could go up to a 9. It could go down to a 7. Those would be acceptable values as well. So you need to be able to use a graduated cylinder. And remember, the rule is your measurement always goes one place smaller than what each line counts for. And if you truly know how to measure, you really don't even need to know that rule. So now we're going to go to a ruler because that's the second skill that we're going to need to know today. So it wants to know the measurement of this A arrow, this B arrow, this C arrow, and this D arrow. So if we look at this first measurement, we go past the 0.1, we go past the 0.2, and it comes up short of the 0.3. So 0.2 something. Each line on this ruler is the tenths place. So that means all of our measurements should go to the hundredths place. I look at that ruler, I look at that arrow, I look at the tip of that arrow, and I do not believe that it is exactly between the 0.2 and the 0.3. So I think it's a little short of that. So my measurement is going to go 0.24 centimeters. I would accept if that 4 was a 5. I would accept if that 4 was a 3. But my true measurement, I really do believe that it is 0.24 centimeters because it's a little short of halfway. I look at B and I start to write down what I know for sure. It is 1 something. It is 1.1, 1.2, 1.3, 1.4. 1.4 something. I think it's exactly on that line. I do not think it's less. I do not think it's more. I think it's exactly on that line. And to do that, I would put a 0 there. And the reason for the 0, this is always my estimated digit. As you've been seeing in the last couple problems, I'm allowing that last digit to vary a little bit. If this digit was gone, then this would be my digit that could vary and go up to a 5 and go down to a 3. Do I think it's 1.5? Absolutely not. Do I think it's 1.3? Absolutely not. I think it's exactly 1.4. So that 0 in my measurement is very important. So the answer is 1.40. Could it be 1.39? It could. I really don't think it is. Could it be 1.41? It really could, but I don't think it is. So those would be acceptable answers. Let's go to C. When I get to C, it is 3, 3.1, 3.2. So I am positive of the 3.2. I can see that it is more than halfway between those two. So I'm probably going to go with a 7 on this one. Again, allowing that last digit to vary by 1 number. I go to 2D. It is past the 4. It is past the 0.6. I think it comes up short of halfway. So I'm going to go with a 4. You could actually go with a 3 as well. So a 3, a 5, I really don't think it is. But again, with our rule of allowing that to vary, we would allow it. All right, so now we're going to actually get into the lab. Again, what we're doing is we're trying to find the density of this metal block that is right here. So what I did is I got you some information, and you're going to figure out the density at home. It says record the appearance of your metal block, and our metal block is silver. Record the mass of the block in data table 1. So on the back side of this sheet, you would record the mass. I'm going to write it down right here, right now, so we don't forget it. 27.80 grams. That is the mass of this block when it was put on a balance. And then it wants me to grab a ruler and get some measurements, get the dimensions of this particular block. So this block is 2.78 centimeters long. It is 1.89 centimeters in width, and it is 1.89 centimeters in height. So if we look at this block, we can see that dimension, the width and the height are exactly the same, but the length is the one that's longer. So you need to do number 4, where you calculate the volume of the block, and then we're going to go and put that on the next page. So you need to do 4, 5, 6, and 7 on your own. On the next page, what you're going to do is you're going to figure out the volume of this block, but instead of using a ruler, you're going to use a graduated cylinder. That's right here. So it says, using the same metal block as method 1, record the mass of the block. Again, I believe we had 27.80 grams. That's going to be in your data table below. It says fill a graduated cylinder about half full with water. And it says record the initial volume of that. And that would be 44.2 milliliters of water when I did the experiment myself. We're going to drop the metal block into that water. Okay, so we have a graduated cylinder. We have some water in it. We drop a block in it, and the water level rose. What did it rise to? It rose up to 54.8 milliliters of water. So it went up to 54.8 milliliters of water. And you can figure out the volume that the graduated cylinder went up, which would be the volume of your block. All right, and then you will finish off that information. Then you had to fill out your data table. So the first one, you used a ruler. And in the second one, you used a graduated cylinder. The mass of the block was the same for both. That was the 27.80 grams, 27.80 grams. This would be the volume of your block from the front page. This would be the volume of your block from the back page. And then you calculate the density, And if they're really close to each other, you know you did a good job. Then you have the next page or two to do as homework. So you have 15.2 to do as homework and 15.3 to do as homework, and then check your answers. Have a good day.